All right, so as promised, before I left class today, I'd do a few extra examples of finding all the evaluating trig functions um, on different problems. So I'm going to start with one where we've just got a t value that we're trying to solve all the trig functions for, and we're given a point because I know that there's a few in your homework where you're just given some x y value, and then you're going to have to find all of the values of those trig functions based on the x y, right? So in that respect, if my sine of t is 2 over 3, and we know that sine equals our um, y value, right? Well, in this case, this is our x and this is our y, so we know that sine of t just equals 3. In the same respect, we know that cosine of t just equals whatever our x value is. And so we look at that x value point and we know that that's going to equal 2. Our tangent of our given point of t is going to equal y over x. Remember that x cannot equal 0 because it's in the denominator and we can't divide by 0. Since we don't have a 0 value, that's really not an issue for us. And we just know that the tangent of t is going to equal 3 over 2. Now, our cosecant of t, well, that is just the inverse of sine. It is 1 over y, which in this case, wanted to make a triangle there. In this case, it's just going to be 1 over 3. Our secant is the inverse of our cosine. So secant of t is just going to equal 1 over our x value, which is 1 over 2. Cotangent is our inverse of tangent. Notice how I try and keep these in the order that I did sine, cosine, and tangent so that I'm getting their cosecant, secant, and cotangent lined up with the ones they're inverses with. If the tangent of t is y over x, then the cotangent of t is just x over y. And in this case, our x is 2 and our y is 3. And so it solves a lot easier when we're just dealing with numerical values, right? None of these had fractions or square roots or anything like that. All the rest of our examples will, because this is almost too easy the way we did this. So in our next example, I am going to do an example where we've got a t equals 5 pi over 4. And again, we are trying to evaluate all 6 trig functions at t equals 5 pi over 4. So we need to know what the xy value is at pi over 4. And lucky for you, I put up a unit circle. So all you have to do is go look for 5 pi over 4, right, which we see right here on the unit circle, and we can find our xy values. Now, lucky that is a 45-degree angle. Anything that's over 4, you pretty much is going to guarantee you a radical 2 over radical 2. 5 pi over 4 falls in this third quadrant, so everything is negative. And so we know that there's an x value, y value there of negative radical 2 over 2 and negative radical 2 over 2. Those are our x, y values. They're exactly the same. They're the same signs. So we just have to perform all the 6 trig functions based on that. So what we can say is that sine of 5 pi over 4, well, that is just going to equal negative radical 2 over 2. In the same respect, cosine of 5 pi over 4, well, cosine is our x value, which is also just negative radical 2 over 2. Tangent, we're going to have to do a little work on, right? Because tangent is y over x. So tangent of 5 pi over 4 is going to be negative radical 2 over 2 over negative radical 2 over 2, right? And the way we solve a problem like that is we're just going to take negative radical 2 over 2, and we're going to multiply it times the reciprocal of the denominator, which is negative 2 over radical 2. And if you notice, that's just going to give us 2 rad 2 over 2 rad 2, and anything over itself just equals 1, right? So that takes care of our three major ones. Now we have to do all their inverses. The inverse of sine is cosecant, and cosecant of 5 pi over 4 equals 1 over sine, or 1 over y. But ultimately what we're saying is it's going to be 1 over negative radical 2 over 2, right? Which is the same as saying 1 times the reciprocal of this fraction, which is negative 2 over rad 2, which gives me negative 2 over rad 2, like so. But I have to rationalize that denominator. I'm not allowed to have a square root in the denominator. So I'm going to multiply this times radical 2 over radical 2. Why would I do that? Because when I multiply these denominators together, I get what's under the radical. And then I wind up with 2 rad 2. And notice those 2's cancel, right? 2 over 2 is just 1, and I'm left with just radical 2. Well, because our x and y values are the same, it's going to make finding our secant really easy, right? Because our secant of 5 pi over 4 is just 1 over cosine, right? It is 1 over our x value, right? Which is the same as saying 1 over negative radical 2 over 2. And I don't need to do all the math on that because it was the same as the last problem. So it is just the square root of 2. Cotangent, on the other hand, is the inverse of tangent, right? Which is saying x over y, right? The tangent is y over x, the cotangent is x over y. But if you notice, our x and our y are the same. It would still be negative radical 2 over 2 over negative radical 2 over 2. And we have done all of the math on that already. So we know that it just equals 1, right? So what can we say? We can say that the sine of 5 pi over 4 equals negative rad 2 over 2. Cosine of 5 pi over 4 also equals negative radical 2 over 2. Tangent of 5 pi over 4 equals 1. Cosecant of 5 pi over 4 equals radical 2. Secant of 5 pi over 4 also equals radical 2. and the cotangent of 5 pi over 4 equals 1. I'm going to do one where we've got a negative, and that should be enough as far as examples go. That should get you far enough into the homework. It should give you a little example of everything that we've got going on. So let's look at one where the example is a t equals negative pi over 3. So if we look at our unit circle, let's bring it down. I wonder if I can just, okay, cool, I can. Let's bring it down to where we are. So notice that pi over 3 is 60 degrees in this direction, right? We're going pi over 3 units in that direction. Negative pi over 3 means we're going pi over 3 units in this direction. So it is the same thing as 5 pi over 3, right? Negative pi over 3 takes us to this spot, right? We're going in a different direction, but it would be the same. Remember when we talked about coterminal angles? It would be the same as if we'd gone 5 pi over 3 in this direction. And so what we know from that is that we've got an x value of 1/2, and we have a y value of negative radical 3 over 2, right? This is our x, this is our y. And that's really the only information that we need to have to find our 6, to evaluate our 6 trig functions at this point. So we can start with sine, right? Sine of negative pi over 3 equals our our y value, right, equals y, which equals negative radical 3 over 2. Our cosine of negative pi over 3 equals our x value, which is just 1/2. Tangent is going to equal y over x. So tangent of negative pi over 3 equals y over x, which for us is going to be negative radical 3 over 2 over 1/2. And so I am going to have to fix that, right? I'm going to have to multiply my negative radical 3 over 2 times the reciprocal of 1/2, because that's how we deal with division of fractions. Sorry, the reciprocal of 1/2 is 2 over 1. And then we can just multiply those together, right? And so I get negative 2 radical 3 over 2. The 2's cancel, right? 2 over 2 is just 1. I'm left with negative radical 3. When I go to do the cosecant of negative pi over 3, we could say that that is just 1 over sine, or we could say that it is 1 over y. But ultimately, what we are saying is that it's going to be that negative radical, it is going to be 1 over negative radical 3 over 2. So I'm going to have to rationalize that denominator, right? I'm going to have to multiply it by its reciprocal. I'm going to go, this is going to equal 1 times negative 2 over radical 3, which gives me negative 2 over radical 3. And we're going to have to rationalize that. We got to get rid of that square root in the denominator, and we just multiply it times itself. So we've got negative radical 3 over negative radical 3, and that is going to give me minus 2 rad 3 over 3. So you do have to play with these a little once you start getting into the inverses. So that handles our cosecant. Our secant is the inverse of cosine, right? So that would be like saying 1 over our x value, right? Which is the same as saying 1 over 1/2, which means that I am going to have to multiply 1 times the reciprocal of 1/2, which is 2 over 1, which just gives me 2. Last but not least, we have our cotangent, which is negative pi over 3. We can see that if tangent is y over x, then cotangent is x over y, which for us is going to equal 1/2 over negative radical 3 over 2. Remember, when we're dealing with a fraction over a fraction, that's saying a fraction divided by another fraction, and the way we handle that is we take the 1/2 and we multiply it by the reciprocal of the denominator, right? We flip it over. So negative 2 over radical 3. Negative 2 over 2 rad 3. These 2's cancel, and I'm left with negative 1 over radical 3. I cannot leave the radical 3 under there, so I'm going to have to multiply times radical 3 over radical 3. I get rad 3 over 3, but with a negative. So we found all of those values, right, for all 6 trigonometric functions. Is it a pain? Sure. But does it get you good at dealing with fractions? Yes. And so I love it because I want you guys to be super confident when you look at a fraction. I do not want you to look at any type of fraction thrown at you and be intimidated. And I think this is a good way to play with them. I think that should be enough in terms of examples that you might run into while you're solving these. I hope it helps. If you guys have any more questions, feel free to just send me an email and we can find some time to go over it. Or use paper. We've got that 24-hour day, 7-day-a-week tutoring site that's always available too. So let me know if there's anything else.